Hello everyone, welcome back to our channel, Array Vigyan Engineering. Today our topic is gamma and beta function. So let's start. See the improper integral. We have already made a video of improper integral. If you don't know, please see the lecture first and then come to this lecture. The improper integral, integration 0 to infinity, e to the power minus x to the power n minus 1 dx. Okay, see this is improper because here upper limit is infinite. So this improper integral is a function of n and is denoted by gamma of n. Okay, so this is the sign of gamma. So gamma of n. This is the gamma function. Okay, where remember n is greater than 0. This is the formation of gamma function. Now if we talk about properties of gamma function, let's talk about properties of gamma function. Okay, the first property is gamma of 1 is 1. Second property is gamma of n plus 1 is n gamma n. Okay, and you have to remember each of the formulas to apply in questions. And another form of gamma of n plus 1 is your n factorial. So you can say gamma of n plus 1 is n gamma n or n factorial. Okay. Now see, because after this gamma n, what you have to do? You have to make this gamma n in the format gamma of n plus 1. So this should be n minus 1 plus 1, right? So it would be n minus 1 gamma n minus 1. Okay. So in this manner it will go, and after that you will get n into n minus 1, n minus 2 to 1. So it would be n factorial. Now our property number 3 is gamma n, gamma 1 minus n is pi by sine n pi. Okay, n is between 0 to 1. Okay, now our next formula is number 4, that is gamma of half is root pi. Okay, now see, let us evaluate some questions. Let us say we have to evaluate gamma of 11 by 2. So gamma of 11 by 2 would be, you can write it in the form gamma of 9 by 2 plus 1. Okay, so this is in the form gamma of n plus 1, so it would be n gamma n. So 9 by 2 gamma 9 by 2. Now again 9 by 2, you can write it in the form 7 by 2 plus 1. Then it would be again 9 by 2, 7 by 2, then gamma of 7 by 2. The gamma of 7 by 2 you can write it as 5 by 2 plus 1. So 5 by 2 will come out. Then gamma of 5 by 2 you can write it as 3 by 2 plus 1. So 3 by 2 will be come outside. And 3 by 2 plus 1 you can write it as half plus 1. So half will come outside. and it would be gamma of half. Now what is gamma of half? Gamma of half is root pi. So it would be, and if you solve this, you will get 945 upon 32, and gamma of half is root pi. Okay. Now if you want to evaluate this, let us say gamma of 7. Now what is gamma of 7? Gamma of 7 is, we can say that it is 6 plus 1, right? So it would be n factorial. So it would be, you can write it as 6 plus 1. This is gamma of n plus 1 format, and you can write it as n factorial, that is 6 factorial. Okay. Now remember one thing, that in this formula we have written it down gamma of n plus 1 as n factorial, but it is only possible when n is a positive integer. N is a positive integer. Okay. For positive integer, you can apply n factorial. If it is not a positive integer, then apply this formula. Okay. That's why we have applied here gamma of n. We have written it down in the form gamma of 6 plus 1. So here 6 is your positive integer. Okay. So that's why it is 6 factorial. Now let us see another question, or you can say example. We have to show that gamma of 1 by 3, gamma of 2 by 3 is 2 pi by root 3. That's what we have to show. So let's see the solution. Gamma of 1 by 3 and gamma of 2 by 3, we can write it down as 1 minus 1 by 3. Okay. And we know that gamma of n into gamma of 1 minus n is pi by sine n pi, where n is 1 by 3. So it would be pi by sine n pi, that is sine of pi by 3. And sine of pi by 3 is root 3 by 2. So it would be 2 pi by root 3. Okay. Hence it is proved. Now let's talk about beta function. What is beta function? Now the improper integral of the form, let me write it here, beta of m comma n is equals to 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 into dx, where m and n are greater than 0. Okay. So this improper integral is a function of n and m. Okay. And it is denoted by beta of m comma n. And remember here m and n should be greater than 0. This improper integral format is known as beta function. Now see, if I tell you that find the value of beta of minus 5,6, will you get any value? No, right? Because here strictly see that m and n are greater than 0. So here m is not greater than 0, so we cannot find this value. So remember this. Okay. And let's see the properties of beta function. So properties of beta function. So our first property is beta of m comma n is beta of n comma m. That is, you can reverse the order. Now our second property is if m is a positive integer, if m is a positive integer, then beta of m comma n is m minus 1 factorial divided by n into n plus n into n plus 1 n into n plus 1 n plus 2 up to n plus m minus 1. So remember, if m is a positive integer, then beta of m comma n, you can write it in this format, that is m minus 1 factorial by n into n plus 1 n plus 2 up to n plus m minus 1. Now our third property is beta of m comma n is twice integration 0 to pi by 2 sine to the power 2m minus 1 into theta into cos to the power 2n minus 1 into theta, cos to the power 2n minus 1 theta into d theta. Okay, this is a very important formula. Remember this. We will apply all this formula. Don't worry. Now, number 4 property is beta of m comma n is integration 0 to infinity x to the power m minus 1 by 1 plus x to the power m plus n into dx. Now our fifth property is beta of half comma half is pi. Okay, this is our fifth property. Now let's move forward and see some example based on these properties. See, let us say we have to evaluate beta of 1 by 3 comma 4. We know that we can reverse the order, right? This is our first property. So we can write it as beta of 4 comma 1 by 3. Now we know the formula, that is if m is a positive integer, beta of m comma n. So here in this case this is m comma n. We can write it as m minus 1 factorial by n into n plus 1 n plus 2. N is 1/3, right? So it would be m minus 1, that is 4 minus 1 factorial by n into n plus 1, that is 1/3 into 1/3 plus 1, 1/3 plus 2 and 1/3 plus 3, to which it will go? It will go up to n plus m minus 1. Here m is your 4, so it will go up to m minus 1, that is 3. Okay, so n is 1/3 and m minus 1 is 3. So it will stop here, 1/3 plus 3. Now if you calculate this value, this is 3 factorial by this thing. If you calculate this value, you will get it in this format: 6 into 3 to the power 4 upon 4 into 7 into 10. Now let's see our second example. Let us say we have to calculate integration 0 to pi by 2 sine to the power 7 by 2 theta cos to the power 5 theta d theta, right? So in this form we can clearly see that this is in this format, right? This is in the format 3. That is twice integration 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. So if you compare, you can say that 2m minus 1 is 7 by 2, and if you calculate m would be 9 by 4, and 2n minus 1 is 5. So 2n minus 1 is 5. That is n equals to 4 by 2, that is 2. Sorry, this is 6 by 2, that is 3. Okay. Now arrange this in this format. See, here we have twice in the formula. So what we can do, that is half multiplied by 2. Integration 0 to pi by 2 sine to the power. You have to write in this format 2m minus 1. M is 9 by 4. So it should be 2 into m minus 1 theta into cos to the power 2 into n. N is 3. So 2 into 3 minus 1 theta d theta. Now what is this value? This value should give beta of m comma n. M is 9 by 4, n is 3. So half is outside. So half of beta of 9 by 4, that is m comma n, that is 3. Now again we can reverse the order according to property 1. That is half of beta of 3 comma 9 by 4, where m is a positive integer. So here we can write it as m minus 1 factorial, that is 3 minus 1 factorial, that is 2 factorial by n into n plus 1. So n is 9 by 4 into 9 by 4 plus 1 into 9 by 4 plus m minus 1, that is 3 minus 1, that is 2. Okay, you have to stop here. Now let's see our next section, that is relation between beta and gamma function. Okay, relation between beta and gamma function. Beta and gamma function. So the relation is as follows. It is beta of m comma n is gamma of m into gamma of n divided by gamma of m plus n. So let's see one example related to this. We have to calculate beta of 4 comma 2. So you can calculate this value by using this relation. This should be gamma of 4 into gamma of 2 divided by gamma of 4 plus 2. Then this is integer, positive integer, right? So gamma of n should be n factorial. Gamma of n minus 1, n plus 1, right? Gamma of n plus 1 should be n factorial. So it is 3 plus 1, that should be 3 factorial. This is 1 plus 1, so 1 factorial. This is 6, 5 plus 1, that is 5 factorial. Now this is 3 factorial, and we can write 5 factorial as 5 into 4 into 3 factorial. So it cancels out. We get 1 by 20. Now let's see another example. We have to evaluate integration 0 to pi by 2 cos to the power 6 theta d theta. Okay. Now see, we know that beta of m comma n is twice integration 0 to pi by 2 sin to the power 2m minus 1 theta into cos to the power 2n minus 1 into theta. So we can write this sum as write this as, see, our formula is integration beta of m comma n is twice integration 0 to pi by 2 sin to the power 2m minus 1 theta into cos to the power 2n minus 1 into theta d theta, right? So here sin term is not there, right? So we can say 2m minus 1 is 0, that is m is our half, and 2n minus 1 is 6. So 2n minus 1 is 6. This implies n is 7 by 2, and we have to divide by here half to get this integral, that means this integral. Okay, so then this should be half of beta of m, that is m is your half and n is your 7 by 2. Now we know the relation between beta and gamma function, that is beta of m comma n should be gamma of m gamma of n by gamma of m plus n. So here we can write half of gamma of half into gamma of 7 by 2 by gamma of half plus 7 by 2. Okay, now let's evaluate this. We know gamma of half is root pi, so this should be half of root pi, and we can write gamma of 7 by 2 as 5 by 2 minus 1, 5 by 2 plus 1. So it should be 5 by 2, 5 by 2, and then we can write it as gamma of 5 by 2 should be gamma of 3 by 2 plus 1. So 3 by 2 will be outside, and then 3 by 2 plus 1 we can write it as half plus 1. So half would be in the outside, and this should be gamma of half, right? Gamma of half plus 1, that is half gamma of half. Gamma of half is root pi, and this is 7 plus 1, 8 by 2, that is 4. Gamma of 4, gamma of 4 we can write it as gamma of n plus 1, that is 3 plus 1, that is 3 factorial, because it's integer, right? So we can say that our value will be 5 pi by 32. If you evaluate, you will get 5 pi by 32. So I think you have got the point how to evaluate this. Now let's see some question. Our first question is, show that integration 0 to infinity e to the power minus 4x into x to the power 3 by 2 dx is 3 by 128 root pi. Okay, so let's see the answer. Integration 0 to infinity e to the power minus 4x x to the power 3 by 2 dx. Now let us put 4x as z. Differentiate both sides with respect to x. We will get 4 dx dz. So dx should be dz by 4. Okay, so it would be, now we have to change the limit. If you put 0, z will be 0. If you put x infinity, z will be infinity. So limit is same here, e to the power minus z, and this x is z by 4, right? So this should be z to the power 3 by 2 by 4 to the power 3 by 2 into dx. Dx is dz by 4. So this should be dz by 4. Okay. Now our next step is, this is 2 square. 2 and 2 will cancel out. Then we will get from here we will get 2 cube, that is 8, right? So this should be 1 by 8, and this is dz by 4. 8 into 4, that should be 32. So this should be 32, 1 by 32, and integration 0 to infinity e to the power minus z into z to the power 3 by 2 dz. Now we can write it in this form, that is 1 by 32 integration 0 to infinity e to the power minus z, and z to the power 3 by 2 can be written down as 5 by 2 minus 1 dz. Okay, now this is the formation of gamma function, right? This is the formation of gamma function. Gamma of n is integration 0 to infinity e to the power minus x, x to the power n minus 1. This is also in the same format, e to the power minus x, x to the power n minus 1. Okay, so this should be gamma of n, that is 1 by 32 gamma of 5 by 2. Gamma of 5 by 2 we can write it as 3 by 2 plus 1, so it would be n gamma n. So 1 by 32 into 5 by 2, gamma of 3 by 2, and gamma of 3 by 2 we can write it as half plus 1. So half will be in the outside, and gamma of half is root pi. So our answer would be 3 by 128 root pi. Okay. Now let's see our next question. Our next question is, express integration a to b x minus a to the power m b minus x to the power n dx in terms of beta. In terms of beta. So in terms of beta function. So let's see the solution. See here we have, and the continuation of this question is, hence evaluate integration 3 to 7 x minus 3 to the power 4 square root of cube root of 7 minus x dx. So let's see the solution. Integration a to b x minus a whole to the power m b minus x whole to the power n dx, right? Now let us put x minus a as z, so dx will be dz, and if you put limit when x tends to a minus a would be 0, then z should be 0, so lower limit is 0, and if you put b in place of x, so then z will be b minus a, so our limit is 0 to b minus a. X minus a is z, so this should be z to the power m into b minus x is z plus a, so this is z plus a to the power n into dz. Dx is dz. Okay. So we can say that this is integration 0 to b minus a z to the power m. This is b minus a minus z to the power, this should be whole to the power n, right? This should be whole to the power n dz. Now what we can do, we can take b minus a common from this. So if we take b minus a, then it will be integration 0 to b minus a whole to the power n. It will be outside in the form b minus a whole to the power n, because here power is n. Then it is z to the power m into 1 minus z by b minus a, okay, whole to the power n dz. So this is b minus a whole to the power n, and now let us put z by b minus a as t. So if you differentiate both sides with respect to t, so then this should be dz equals to b minus a into dt. Okay. Now if you put 0 here in place of z, then t will be 0. If you put b minus a in place of z, it would be 1. So limit is 0 to 1, and z is b minus a into t. So it should be b minus a to the power m into t to the power m, and z by b minus a is t, so it is 1 minus t to the power n, and dz is b minus a dt. So this should be b minus a dt. Okay. Now b minus a to the power n and b minus a to the power m. So base is same, all of the powers will be added up. So b minus a to the power m plus n plus 1 integration 0 to 1 t to the power m into 1 minus t to the power n dt. Now see, what is the definition of beta function? Definition of beta function is beta of m comma n is integration 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1. So you have to write in that format b minus a to the power m plus n plus 1 0 to 1 x to the power m minus 1. So you have to write m minus m plus 1 minus 1 and n 1 minus x, that is 1 minus, this is t, right? 1 minus x, that is here we have 1 minus t to the power n plus 1 minus 1 dt. So it is exactly in the same format. So we can say that our m is m plus 1, n is n plus 1. So this should be b minus a to the power m plus n plus 1 beta of m plus 1 beta of m plus 1 comma m plus 1, right? Now we have to evaluate this integral 3 to 7 x minus 3 to the power 4 square root cube root of this thing. So second part is integration 3 to 7 x minus 3 to the power 4 cube root of 7 minus x dx. This is integration 3 to 7 x minus 3 to the power 4 into 7 minus x to the power 1 by 3 dx. Now we already know that comparing this thing with the format we get. So we can see that here uh, this is t to the power m plus 1 minus 1 format, and this is 1 minus t to the power n plus 1 minus 1 format, right? So ultimately we can say that this is b minus a. So b is 7 because we have to compare with this format, right? A to b, x minus a to the power m, b minus a to the power n, and you should compare this thing with this thing, right? So here a is 3, b is 7, a is 3, c, b is 7, c, and this is b minus x to the power n. So 7 minus x to the power n. N is 1/3 and here m is 4. And we have just evaluate this integral in this format. So comparing with this, we can say that b minus a is your 7 minus 3 to the power m plus n plus 1. So m is 4 and n is 1/3. So this should be 4 plus 1/3 plus 1 and beta of m plus 1, that is 4 plus 1, and n plus 1, that is 1/3 plus 1. Okay. So this should be 4 to the power 16 by 3, and this should be beta of 5 comma 4 by 3. Now we know the relation between beta and gamma. So if you convert this into gamma, it will be easy to evaluate. So it would be 4 to the power 16 by 3 into this is 5. So we will have gamma of m minus 1, right? So it would be 4 factorial by n into n plus 1. So n is 4 by 3 into 4 by 3 plus 1 into 4 by 3 plus 2 into 4 by 3 plus 3, and see we have to go up to m minus 1, that is 4. So 5 minus 1, 4. So next term is 4 by 3 plus 4. So this is your answer. Now you can calculate the values, but I think this is not required. Now let's see another question, that is prove that integration 0 to infinity e to the power minus x to the power 4 into x square dx multiplied with integration 0 to infinity e to the power minus x to the power 4 into dx, which is pi by 8 root 2. Okay, we have to evaluate this integral. So let's see the solution and we'll wrap up after that. So let us say x to the power 4. Let us take x to the power 4 as z. Then differentiate both sides with respect to x. It would be with respect to z. It would be 4x cube dx. That should be dz. Or we can say that dx is 1 by 4 z to the power minus, this should be dx is dz by x cube. Okay, let us write it first. 1 by 4 into 1 by x cube into dz. So x cube is, x is z to the power 1 by 4. This should be 1 by 4 into x is z to the power 1 by 4. So here is 3. So we have z to the power 3 by 4 into dz. So ultimately we get 1 by 4 into z to the power minus 3 by 4 into dz. Now we have to change the limit. So we can see that when x is 0, z should be 0, and when z is 0, x is infinity to the 4, this will also be infinity, so z is infinity. So our limit is, our integral is 0 to infinity e to the power minus x to the power 4 x square dx into integration 0 to infinity to the power minus x to the power 4 into dx. So you can write it as 0 to infinity x to the power 4 is z, so it should be e to the power minus z, and x square would be z to the power half, right? If you divide by half both the sides, you will get x square as z to the power half. So x square, in place of x square, we can write z to the power half, and dx is 1 by 4 z to the power minus 3 by 4 into dz into integration 0 to infinity e to the power minus z, and dx is 1 by 4 z to the power minus 3 by 4 into dz. Okay. Now this should be 1 by 4 multiplied by 1 by 4, that is 1 by 16 integration 0 to infinity e to the power minus z, z to the power, this is z to the power minus 3 by 4, z to the power half. So z to the power minus 3 by 4 plus half, it should be z to the power minus 1 by 4 into dz multiplied with integration 0 to infinity e to the power minus z, z to the power minus 3 by 4 dz, right? This is in the form of gamma function, right? This should be 1 by 16, gamma of n is 1 by 4 plus 1, and here gamma of n is minus 3 by 4 plus 1. Okay. Now let's evaluate this. This is 1 by 16, gamma of minus 1 by 4 plus 1, that is 3 by 4, and this is minus 3 by 4 plus 1, this should be gamma of 1 by 4. So gamma of 3 by 4 can be written down as 1 minus 1 by 4. This is in the format, in the previous format, so we don't have to write it here. Okay, let's see. So 1 by 16, gamma of, we can write it as 1 minus 1 by 4, gamma of 1 by 4. So this should be 1 by 16 into, this is the, from definition we can say this is, from property we can say that this is pi by sine of n pi. So n is 1 by 4 pi. Okay, this is the definition. If you forget, let's see the formula. This is gamma, right? Let's see the property. Gamma of n, gamma of 1 minus n is pi by sine n pi. Okay, so gamma of n, gamma of 1 minus n should be pi by sine n pi. So we are almost done. This is 1 by 16 into pi by sine of pi by 4 is 1 by root 2 So this should be root 2 will go in the numerator, or this is root 2 pi by 16. If you multiply it by root 2 in the numerator and denominator, 2 and 16 will cancel out. It would be pi by 8 root 2. So hence proved. This is the thing we have to prove. Okay. So I think you got the point how to calculate gamma and beta function, and the basic thing is here that you have to match with the format and match with the formulas you have learned. It's a very easy chapter, but you have to practice some questions in order to get perfection. So that's all for today. Have a good day.